In this part, we're going to determine the expression of the current I in terms of time and represent it graphically. Let's consider the expression of UC as function of time. It's E exponential minus T over tau. Its derivative is E, derivative of the exponential is minus 1 over tau, exponential minus T over tau. It means minus E over tau, exponential minus T over tau. Now, during discharge, the current leaves the positive plate of the capacitor. If we choose the positive sense as entering the positive plate of the capacitor, we follow the direction of the positive sense. So I equals plus dq over dt. It means plus c duc over dt. Then I equals plus c times expression of the derivative of UC as function of time is this one. So times minus E over tau exponential minus T over tau. So it is C times E or minus C times E over as tau equals RC exponential minus T over tau. Simplifying C and C, it's equal to minus E over R exponential minus T over tau, or minus I max exponential minus T over tau. Now, as I equals minus E over R exponential minus T over tau, at T0 equals 0, I equals minus E over R exponential 0. Exponential 0 is 1, so minus E over R. At T equals tau, I equals minus E over R exponential minus tau over tau. It means minus E over R exponential minus 1. So it's 0.37 minus 0.37 E over R, or minus 37% from E over R, or from I max. At T equals 5 tau, I equals minus E over R exponential minus 5 tau over tau. Exponential minus 5 is approximately 0, so I approximately 0 amps. Now, representing the current I as function of time, at T equals 0, it is, or it starts from minus E over R. At T equals tau, it reaches minus 37% from E over R. And at T equals 5 tau, the transient phase ends and the permanent phase starts. So the current remains approximately 0 amps. So it is of this form, or it is, here we have a clear representation of the current I as function of time. Here we have a remark: if 5 tau exceeds the half period, the capacitor cannot be fully charged or completely discharged. Okay, so the variation of UC as function of time will be of this form. So we'll not have a permanent phase where UC becomes constant equals to E or approximately equals to E when it's fully charged, and the capacitor will not be equal to 0 when it is fully discharged.